Hello, welcome back to Thrifty Tool Shed. Today I thought we'd take a look at another PEEK product. It is the PEEK DCA55T. It's the semiconductor component analyzer. It's very similar to the PEEK ESR meter that we tested in the previous video, but I thought we'd have a look at this one since it's a semiconductor component analyzer, and maybe just look at the comparisons between some of the readings from the DCA55 and the GM328. So let's see what it does. Just a quick look at the Atlas DCA55. The user's guide, some of the summary features of the type identification, just shows how to analyze the component. It does have the handy 3 leads. I will say before we get started that keep in mind that it is a semiconductor component analyzer, and as far as resistors and capacitors, I'm not even going to waste time trying to show them test that, whereas the GM328 will very handily check these and tell you what they are in circuit or out of circuit, in most cases in circuit. But this is strictly for semiconductors, so things like transistors, and you saw the list there on the, or off of the owner's manual user guide, rather. But we'll get into checking transistors and maybe some tracks and Zener diodes and maybe even LEDs. So we'll just give a comparison so you'll see how they compare and how they stack up. So first of all, I do have data sheets on some. I won't bore you with all the details of all the tests. Speaks just a comparison, but on this C3953, I do have the data sheet for it. Shows us the NPN. A current gain of 60 to 120. Emitter the base saturation voltage, probably less than a volt. 1 volt max on that. So let's see. These are used, but some I've taken out in the years past and just kept. I'm going to try my best to keep this going the same sequence on these so it shows up. Try to do red, green, blue. It doesn't matter, just so you're used to seeing it in that order. Let's hook it up and hit the button. Analyze it. It shows that it is a NPN silicone transistor. Press this button to scroll down. Red, green, blue is emitter collector base. That is what the data sheet showed as well. One, two, three, ECB. Keep going down for more detail. It shows a current gain, or HFE, of 81, which is right in the middle of that, I believe that, yep, 60 to 120. And also shows the test current, but also the voltage on the base to emitter is 0.74, so definitely under a volt. Okay. We'll try to do 1, 2, 3 here. Again, not that it matters. It also shows NPN, ECB, HFE of 85, which is very similar And it also shows 699 millivolts, which is about 0.7. I think the other one showed 0.74, I believe. So yeah, shows you a little pinout. So both of those tested that very well. Next up, we have a NEC D381. And on this one, I also have the specs printed out. Red. Keep it red, green, blue. Just for clarity. It is a MPN. Base collector emitter, which is what it shows. 1, 2, 3. I kept it in order to 1, 2, 3 so it would show up the right way there. Once again, doesn't have to be, just for clarity. It shows the current gain of 77, which on page 2 shows at the bottom that 80 to 160, so it shows just shy of that. And 0.66 on the voltage BE, and should be less than 1.5. Try to stick to the 1, 2, 3. So we see again BCE. See a HFE of 87, which does show about 10 higher than the peak unit. And that is actually in range, according to this data sheet. I know this is a 2S, by the way, a 2S D381. I know that's probably not the same manufacturer, but it's probably pretty close on the spec. So I would say the transistor's fine according to that. And they both showed a very similar result on the test. Really helpful when you don't know what it is or don't have the data sheet handy. Next up, I have a little C2688. We'll do red, green, blue for 1, 2, 3. MPN, ECB, 143 on the current gain, and 0.7. Get that, there we go, that's 1, 2, 3. Well, it shows a 133. It also shows ECB, I'm sorry, 133 on the gain, and 0.5859 on the forward voltage. Very good. I don't have the data sheet on that one. This one first. Red, green, blue. So this one shows us the enhancement mode in channel MOSFET. Gate drain source. The gate threshold voltage of right at 3 volts, 2.99. Test current it used. We're back to the beginning. So that's pretty handy. It also shows an N-channel enhanced MOSFET, gate drain source. It shows 3.1 on the voltage threshold. So, very close. And on that one, all I printed out on it is that it was a MOSFET N-channel. I don't have all the specs on that one. Next, I have a triac. It is a ECG5614. Unknown or faulty component. Shows a resistance between 1 and 3 of 34.9 ohms. Yeah, I think that one's toast. File. That was just some information on that, but it's just showing us a track, but it's toast. Next up, I have a C3486. NPN silicone transistor, BCE, current gain of only 6, 0.56. C1. I can do 1, 2, 3 there. It's a little unusual. BCE showing a gain of 8 and 567 millivolts, so those are fairly close in reading. Don't have the spec on that one, but this one is a little, sorry, 2N3904. Little high gain transistor. NPN. Oops, hit the wrong button. NPN, double checking it. EBC, gain of 157. Test current and 0.74 on the base to emitter voltage. One, two, three is EBC, gain of 169 and 718 millivolts. So very close on that one, and I do have the specifications printed out on that one as well. EBC, and it should be somewhere in the gain from 100 minimum to 400, so it's well within that. And the saturation there, I didn't highlight it, but it's right there. The next thing I wanted to check is the only information I could find on a, you can see this up here, Still in the heat sink where I took it out of a board. It's a L6008LS. It is an 8 amp sensitive triac. That's the pin out for it. It shows a sensitive or low power triac, which is exactly what it is. It shows red, green, blue as gate M2, M1. One more thing. Nope, that's it. Shows you the pin out and what it is. So that's handy. Now this is one thing with the 328. It actually shows that it's more like an NPN transistor. So that is the difference on tracks. None of the tracks that I've had actually showed exactly right on, and this one may not show a track. I'm still not 100% sure since I don't deal with them a lot. So it doesn't really even matter to me, but I wish I did have some more to test with sometimes. Just on a generic diode here, ERD0302. Let's see, we'll do red to the cathode since it's got the indicator, and we'll just do green to the anode. And it shows that it's a junction or diode junction. And it shows the red's the cathode and the green's the anode. And it shows a forward voltage of 0.58 volts. It also shows the test current. Now on this one, it's a little bit more difficult. It don't fit in there. I could do leads, but it would really probably mess up the forward voltage check, but I can actually on the pads put it right here between, I'll just do 1 and 3. Get my fingers off the leads. I'll do across 1 and 3 with the cathode actually on 1. And there we go, it shows the cathode on 1, anode on 3. And it shows 0.6 or 602 millivolts. So that showed correctly on both as well. Next I have a Zener diode. I have a 3.3 volt Zener diode. Again, red on the cathode, green on the anode. It shows that it's a diode junction or LED. It shows red that's on the anode, green's on the cathode. Well, wait a minute. So that didn't show forward, that showed actual reverse. So it shows a forward voltage, which is really the reverse voltage of 2.15 volts. Now I know this in the package is a 3.3 volt Zener, but it showed a little bit low. Now the 328 does the same thing. I don't deal with Zeners a whole lot. I do have this across 1 and 3 with the cathode being on 1. And this is where the GM328 shines. It shows that it's a dual diodes network. It shows the forward voltage of it in this direction and then this direction. So this is truly your forward and this is truly your reverse. So that one showed 2.15 on reverse, I believe it was. Yeah, 2.15, 2.23. So they show pretty similar on that, but that one did better on the track that I could test, and this one did better on the Zener. But the limit to the Zener, as I mentioned on the full review of this thing, somewhere under 5 volts is its limit. And to show that, I do have an 8.2 volt. So I'll take an 8.2 and do red to cathode, green to anode. It shows a diode junction, and it shows the reds on the cathode, greens on the anode, and it shows 0.76. So, and it shows the test current. So it does show at least that it's a diode and the forward voltage. It doesn't check the reverse on that one. So let's put it in this one. Cross 1 and 2, where the cathode going to 1. And it shows also that it's just the forward voltage, like it's one diode, because it don't have enough power to overcome the reverse junction. So, but it at least does give you the, as this one, it gives you the forward voltage. At least you know the diode is okay in the forward direction. It's not shorted or open. Well, lastly, I just thought we'd check a few diodes, LEDs rather, light emitting diodes. Just let you see kind of how, because it kind of lets you know how it checks a device with the LED, because it blinks it. So it let us know that it's a LED or diode junction. It lets us know the connection, cathode, anode, red, green. It lets us know the forward voltage of 2.82, which for a white diode it would be a higher voltage. Lets you know the test current it tested it at. Cross 1 and 2. See it blinking as it's testing, and it shows 2.87, so it's pretty close. Shows the direction of the pinout. We'll show a green because it should be a lower forward voltage on the green LED typically. Shows us the correct device. Anode, cathode, red, green. Forward voltage of 1.94. Shows the test current. So the green LED on the GM328. 1.97 shows the right pinout. And lastly, I thought we'd do a red LED. Go back to this one. Shows LED, cathode, anode, 1.76. Gives our pinout and 1.8 volt. So that's just a quick little comparison between the two. I do use this one for a lot of things because the little leads are just quick, easy. This one's nicer with components you can stick in sometimes. But they both have their advantages in different areas, and they both actually tested components very, very well. Hope you got a little bit of information between the two out of the video. If you liked it, give it a thumbs up, and please subscribe. Thanks for watching.